Alright, today we're going to focus on domain. We've done domain in the past, so let's see what we remember about it and how we're going to make this to the next level. So we are doing domain algebraically, graphically, and by content. This will help with ACT, guys. Alright, so the domain of the function is the inputs. So from left to right, how far? And we do it in interval notation. Now be careful with interval notation because we want to remember that we have to justify whether we're using parentheses or brackets. Okay, and one side could be parentheses, the other side could be a bracket. It's okay. So algebraically, we're going to look for things that cannot happen. So some things that we want to focus on is that we cannot divide by zeros, and square roots cannot have negative numbers under there. We want to keep in mind that even though it says square roots, it also means all even roots. So 4th root, 6th root, so on and so on. Alright, so find the domain of f of x equals 4x plus 1 all over x minus 5. So let me remind you of the parent function. So 1 over x is the parent function. And our graph looks like this. So the idea is that there's an asymptote at 0. This is why for functions that look like this, the rational, we need to make sure that the denominator does not equal 0. So we set our denominator not equal to 0, we solve, and then we put it in interval notation. So in this case, negative infinity to 5, 5 to infinity is parentheses because it cannot be 5, and it's parentheses around negative infinity and infinity because it never gets there. If we were to graph this, there would be an open circle at 5, and it would be highlighted in both directions. Okay. Here we have 3 times the square root of x plus 1 minus 6. So if we remember correctly, the parent function for this is kind of like a rainbow. And as you can see, there are no negative values. Now where we get that is that under the square root cannot be negative. Those other numbers have nothing to do with it. So we're going to just set that x plus 2 has to be greater than or equal to 0, greater than for positives and zeros because the square root of 0 is okay. And then we solve, get x by itself. We see that x is greater than or equal to negative 2, so the lowest value is negative 2. It's a bracket because it's equal to, and we're greater than, so it goes to infinity. So in this case, if we were to graph it on a number line, you would have a filled in circle since it's equal to, and we go to infinity. Alright, so let's do some of this practice together. So again, this is a rational with a denominator. So what do we have to do? We set the denominator not equal to 0. We're going to solve. So of course we have an x squared and x in here, so we're going to factor. I'm going to allow you guys to factor whichever way you want, but in the end, you need to have x minus 4 times x plus 2. Don't forget, it does not equal 0. So the first part would give us that x can't equal 4. and x can't equal -2. We get that from the two binomials. So let's put this in interval notation. You want to go left to right, so we're going to start with -infinity. And then we go to our lowest value, which in this case is going to be -2, parentheses. And then we start back up at 2. We have parentheses, so it's not including 2, so it's okay. -2 to, we have 4. And then 4 to infinity. So the only values that do not make this a full -infinity to infinity would be -2 and 4. These would be your asymptotes. B, well, let's look at this. Let's look at the parent function of x squared. X squared is that parabola. So let's talk about domain, x values, and restrictions. Well, is there any problems going on here? Are there any holes? Are there any asymptotes? Is anything not covered? Well, let's see, all the way to -infinity, all the way to infinity. So we're okay. Since there's no problem, the domain is automatically -infinity to infinity. C, we have a square root. Remember, the only thing we care about is what's under the square root. So we have 3 minus 2x. And what happens with the square root? It has to be positive, and it can equal 0. So we want 3 minus 2x to be greater than or equal to 0. We solve. First thing we're going to do is subtract 3 from both sides. Then we're going to divide by -2. When we divide by a negative number or multiply by a negative number, what happens to the inequality? Well, it switches. Then a -3 over a -2 is a positive 3/2. So say this out loud before you write your interval, because this is x is less than or equal to 3/2. So we want to think of it as it's less than, which means we start at -infinity and we go to 3/2. Now it can equal 3/2, so that's a bracket. That's our algebraically. Now let's look at the graph. What we want to do is go left to right. So some things I want to point out are asymptotes, or where something stops. Okay. What I might do with the asymptotes is then put the interval down here so I can see exactly where I'm going. So this part of the graph, this keeps going, guys. These are arrows. So if we talk about left, we're going from -infinity and we hit this invisible wall at -4. Now we actually don't hit it right. We come very, very close, so it's parenthesis. Then we start on the other side of the wall and go to the next wall, which is 2. And then on the other side of the wall, and we keep on going to infinity. Okay, just like on B here, it keeps going, and all the way left means -infinity. And then as we go right, all of a sudden we get to 4 and we stop. We don't stop at 2, guys. That's a y value, and our domain are x values. So we stop at 4. and we hit 4. It's a closed circle, so it is a bracket. Now we have a cubic. Remember what we're looking for: any issues, any holes, any asymptotes, anywhere it stops. But it doesn't. If we kept going, this would go out all the way left, and this would keep going out all the way right. So no problems. Our domain is negative infinity to infinity. Alright, let's talk about actual scenarios. Okay, so example 3 here, you might have not done this before, or you might remind yourself something from last year with it, but I'll explain it out. So a square of side x feet is cut from each corner of a 12 feet by 6 feet piece of cardboard to form an open top box. Determine the domain of the volume function. So volume, remember volume is length times width times height, and we have to think of volume as a measurement, and volume can never be 0 or negative. It can't be 0 because we wouldn't have a 3D object now. So let's draw this out so I can show you what it looks like. So we have our cardboard box, and we're cutting out these squares. These squares are x by x. Okay. Now the length of the total side is 12, and this one is 6. Alright, so if we were to cut those squares out, what would be the new length? Well, if I take away both of these, I'm saying 12 minus 2 x's. So that is my length from here to here. And then same thing with this side, we're taking 6 and we're subtracting 2 x's. Alright, so when it comes to volume, let's talk about length, width, and height. So our length in this case would be 12 minus 2x. Our width would be 6 minus 2x. And our height, well, think about our height. These dotted lines are where we would fold up. So if you talk about the height, it's going to be height x. So let's make our volume function. So volume, v of x equals our length times width times height. Now there are many ways that we could solve this problem, but we are just going to use our calculator. So the first thing I want you to do is go to y equals and plug in your function. So x times 12 minus 2x times 6 minus 2x. Oops, x. Now there are also two ways we can do this. We can go do second trace and go to our zeros, because we're going to say where this equals 0, because it can't be a negative number. Or we can put 0 as our second function and find where they intersect. Second trace, intersect. Okay, on the window, very quick, let's talk about min and max. X cannot be a negative number. So I put it at -1 just so I can see the x and y axis. I'm hoping that we're not going to get very much bigger than 5, so you can put 10 if you want. The same thing, I want to see the y value, so I know the volume itself is not going to be a negative number, so I put a -5 just to see the y-axis and the x-axis. So, and then maybe I want to try to get the max volume in there, so I'll just put 20. Alright, so when I graph it, what I'm really looking for, guys, is where it hits 0. Okay, I want to see the greatest value of x, and the smallest value of x. Okay, so second trace, I'm going to do intersect since I put 0 as y2. It's following my volume graph. I'm going to make it follow my 0 by pressing down. Now I can see that flashing dot. I'm going to go over to my first intersection. 1, 2, 3. So I see the lowest value is 0. Let's do that again and find the max. Not technically the max, but where the volume would also equal 0. I press down to follow the 0 curve. Otherwise, I'd have to wait for it to come all the way around the other one. So get really close to it. 1, 2, 3. So as you can see, it's a 0 volume when x is 3. Okay. Some of you that might have gone up to 10, you realize, hey, it goes back up here. So I'm going to show you that really quickly. I'm going to go to 10, see what happens. So see, it comes back up. Let's talk about that in a minute. So that's probably what, at 6, 3, 4, 5, 6. If I plug in this 6 to x, I'm okay here. If I plug in 6 here, I get 12 minus 2 times 6. Well, 12 minus 2 times 6 is 0, so that's what we wanted to find. But if you look here, 6 minus 2 times 6, this would be a -6. Can we have a negative width? No, it doesn't exist. So my only values are between 0 and 3. So again, even if you see the third intersection, once it turns negative down here, we disregard anything on the right. Now let's talk about parentheses or brackets. If we include brackets here, we're going to include 0 and 3. But again, our width would be 0 or our height would be 0. Well, if we have no height, do we have a box? No, we just have a square of cardboard. We don't have a volume. So what we're going to do is put parentheses because we don't want to not have a volume. And this is our answer. Again, because our volume, we don't want it to be 0, otherwise we won't have a volume, and we don't want it to be negative because negative dimensions do not exist in real life scenarios. Example 4. The path of a ball thrown straight up can be modeled by the equation h of t, where t is the time in seconds that the ball is in the air and h is the height of the ball. Okay, so our x-axis is the time and our y-axis is the height of the ball. So this graph is going to look something like this. You throw a ball, right? But of course, do we talk about negative time? No, it doesn't exist. We can't go back in time. Also, can our ball, do we talk about it going below the ground? Because you got to remember that this is the ground level. Okay, so we're looking at from where time is 0, course, we know time is 0 because that's where we start. We're going to find out where it hits the ball or the ground. So go back to your calculator. We're going to put in our equation, -16. We're going to put x squared plus 48x plus 12. I like the intersection button, so I'm going to keep y2 as 0. Let's see if our window's okay. Our windows are okay. Look, you have the first intersection at 0, which is fine because we already know time can start at 0. We need to find this one right here. Okay, so again, that window goes out to 10. If you want, you can make it go out to 5, and that should be okay. So second trace, I'm going to do intersection since I did y2. I am going to make it follow the second y because I can't find the flashy dot. So I'm going to bring that down. So see, it's following the 0, and there it is. So I'm going to get it really close. 1, 2, 3 for the equals button. And so I get about 3.23, and then of course that's seconds. So let's talk about parentheses and brackets. Parentheses means it never gets there. Well, guys, can time equal 0? Yeah, it's your initial time. So we can do a bracket around 0. Well, can our time be 3.23 seconds? Yeah. And can it reach the ground? Yeah. So we're going to put a bracket around 3.23. So make sure you know the difference between the parenthesis and the bracket. Also, I'm going to put it in interval notation, but also be okay with writing a sentence about it. You know, the domain or time can be set between 0 and 3.3 seconds. The length, width, and height can be 0 or start at 0 to 3 with parentheses around it. Alright, start your practice.